everyone, so welcome to my YouTube channel. So guys, in today's video for the thermodynamics we are going to continue with we are going to continue with the Hess law. So if you want the whole video for that, so you have to go to my channel, then go to the playlist. In the playlist you will get the thermodynamics, so there you can get it. Okay, so guys, Hess law, and then another like one or two video, I think so, one video, another next video. Okay, like next video, not another next video, means another one video, you can say the next video, this thermodynamics will get over, and then one more video in which we will solve all the examples and the exercise questions of thermodynamics from Ncert. Okay, because main thing is the problems, the examples, questions, and the exercise questions of the Ncert. That is very, very important. Okay, so we will see the Hess law. Okay, Hess law or Hess's law or Hess law, whatever you can say, it's a law. Okay, so here what we have to understand, I will write the Hess law in a simple definition so you can understand it properly. So Hess law means we will say the enthalpy change. अरे नहीं चाहिए भैया. Okay, the enthalpy change for a reaction. Okay, so enthalpy change means what? We are talking about delta H. Obviously enthalpy change means what? Delta H. So the enthalpy change for a reaction is the, okay, the enthalpy change for a reaction is the same whether the reaction, okay, Hess law means Hess's law or Hess law. It's what? The enthalpy change means we are talking about delta H. So enthalpy change for a reaction is the same whether the reaction takes place in one step or through several intermediate steps. Okay, so Hess law means we'll talk about delta H. Hess law means we'll talk about the delta H, means enthalpy change. If we'll talk about the delta H for a reaction, means suppose if I will take any reaction, suppose if I will take a reaction is this A plus B gives suppose C plus D. Okay, so I see they said the enthalpy change for a reaction. So if we'll talk about the delta H for this reaction is the same, it will remain same whether the reaction takes place in one step or through several intermediate steps. Okay, so this means what? This means that if there's, like, if we have to find the delta H for this reaction, so either if I will go in a one step like this step, if I will go in a one step this step, if I will go in a one step this step, so delta H for this one step, or delta H whether the reaction takes place in one step or through several intermediate steps. Okay, if the reaction is taking place in just one step or several intermediate steps, so what will happen? We will get the delta H, means enthalpy change will remain same. This wants to say the Hess law. Means the simple thing is, if any reaction is happening, okay, if you will do the reaction directly in the one step, or if you will find, right, means reaction is what will happen, reactant reacts with each other and will give the product. So reactant react with each other and will give the product, so you will get a direct one step. So for that delta H, or for reactant you will react, you will get some other product, then again product. Okay, you will do the reactant and all, So reaction and all, what will happen here? If we are doing reaction in one step, where we will get the reactant, will get the product in one step, so that delta H, or if we are getting the reactant and product in several steps, so that delta H will remain same in the His law. Means His law does not depend upon the path. His law is what? His law says that, His law said that it does not depend upon path. It depends upon initial and final value. Means reactant and product, that's it. It does not depend like which path we are following, how many steps we are following to get the product. It's not like that. Either from reactant we'll get the product in one step, or either from reactant we'll get the product in 2 steps, 3 steps, 4 steps, 5 steps. It does not depend. Every time, every condition, delta H will remain same. Either you will do the, means you will get the product in one step from reactant to product direct, or if you will get the reactant to product in 3 steps, 4 steps, 2 steps, whatever. So each condition, delta H will remain same. Delta H means enthalpy change will remain same. This the His law wants to say. Okay, so just as an example, if I will tell you to go down, okay, suppose you are in the 3rd floor. If I will tell you to go down, you have to reach to the ground floor. So what are the conditions? You can go by stairs, one path. You can take a lift, you will go through lift, second path. Third path is third path you can say you will jump direct. So what will happen? Final is product means we are reaching to the ground floor. So that is the thing, that's what the His law says that. Okay, either you go direct in one step, or you go by several steps to the final product. Whatever you will take, the enthalpy change will remain same. This is very important. Okay, let's take one example for the reaction. So what you have to do, you have to write this definition of enthalpy change. Okay, so it wants to say that this enthalpy change. Okay, enthalpy change for a reaction, enthalpy change for a reaction equals to summation of enthalpy change of steps. Summation of enthalpy change of steps. Okay, so here you can write, this means that what? Enthalpy, we know, see delta means what? Any delta. If I will write any delta, it is a what? It is a state function. It is not a path function. Any delta U, delta H, any delta you will take, guys. Delta is there, delta E. Okay, if delta is there, delta means it is a state function, initial value and final value. Delta V, initial value, final value. So whenever we'll take the delta is a delta is a initial and final, means state function. Delta is not a path function. So that's why here they said the enthalpy change. Enthalpy change means delta H. Delta H for any reaction is what? It does not depends upon the path. It depends upon the final product. So whichever you will take the path, 1 step or 3, 4, 5 steps, whatever, delta H will remain same for every steps. Okay, so you write this definition and then write down this. Okay, and if you want, you can write that this also, enthalpy change is a state function. It does not depend on path function. Okay, fine. After that, I will explain you with the help of one example. Let's see. Suppose this is a one like reaction in one step. Okay, suppose this is a one reaction, like carbon in the solid form reacts with oxygen in the gaseous form. It will give carbon dioxide in the gaseous form. So for this, okay, plus heat, because any reaction is happening, what is happening? Any reaction will take place, what is happening? Heat is, right? Heat is there, means, okay, so what will happen? Heat evolved. Okay, so delta H. So that's why, see here, if I will take this, what, from carbon we have to make carbon dioxide. What is our main process? From carbon we have to make the carbon dioxide. So from carbon we have to make the carbon dioxide. This I made in a single direct one step. So for that, delta H is what? Delta H is minus 393.5 kilojoule per mole, delta H. Okay, but another I will take another example. I will take where the same thing, from carbon I have to make carbon dioxide, but this time not in a one step, this time in a several steps. So let's see. From carbon, okay, carbon reacts with half O2 gas form. We will get the carbon monoxide, the gaseous form. So for this delta H is equals to, we have minus 110 minus 110.5 kilojoule per mole. Okay, and then next step is what we get, we got carbon monoxide. Again we will take the carbon monoxide, reacts with again half O2, which is gas. We will get carbon dioxide in the gaseous form. So again we will get the delta H for this reaction is minus 283.0 kilojoule per mole. Okay, so what we get to know, from carbon we have to make carbon dioxide. So this we took direct in a one step. So direct in a one step we will get the enthalpy change, means delta H is this much. Enthalpy change means delta H will get this much. Okay, now next thing is, again we will take carbon. From carbon we are making carbon dioxide. From carbon we are making carbon dioxide, but this time from carbon we are making carbon dioxide, but this time not in a single direct step. This time we have taken a several steps. So maybe 2, maybe next time 3 steps, 4 steps, whatever, who knows. So here several steps means 2 steps. So what we will do, we have to find the final reaction. So what is this? See, enthalpy reaction means you have to do the sum of enthalpy of every step. Sum of enthalpy of every steps. So what we have to do, sum of enthalpy of every step. So this is the first step, minus 110.5 sum, plus this is for the second step, minus 283.0, right? What we have to do, we have to do the enthalpy reaction, enthalpy of the reaction. See, enthalpy of the reaction is what? Enthalpy of the reaction is sum of enthalpy change, sum of enthalpy change of every steps, sum of enthalpy change of every steps. So what will happen, sum of enthalpy change of every step. So for this step we have enthalpy change is this much, okay, plus next for this step we have enthalpy change is this, minus 283.0. so when you will do, it will become minus 110.5 plus minus 283.0. So when you will add this, you will get plus minus 393.5 kilojoule per mole. Okay, so see this, what is the thing? Thing is same. See here, we have to find from carbon, we have to find carbon dioxide. So this we have taken in a one step, single step. So we get change in enthalpy is this one, minus 393.5 kilojoule. Now again here carbon, from carbon we are getting the carbon dioxide. Again from carbon we are getting a carbon dioxide. So what is happening here? But this time we are not doing in one step. This time we are doing in several steps. So again for that also delta H, we are getting enthalpy change for whole reaction is the same. So that's why this is what the His law wants to say. Either you are doing in one step or either you are doing several steps, delta H for the reaction will remain same. So how you will find the delta H for the delta H like of reaction for several steps? So just we have to add the delta H for every steps. We have to add the delta H for every steps. You can see a delta H for reaction is what? Summation means addition of delta H for every steps. The same thing we did here. Okay. Yeah. Now we will solve the problems. Okay. Fine. So see, this is the following reaction. Carbon in solid plus oxygen in the gaseous form gives carbon dioxide in the gas form plus X kilojoule. Okay, then they said this carbon, mean the next reaction, carbon monoxide in the gaseous form reacts with half O2 in the gaseous form. It will give, this is a question is, it will give CO2 in the gaseous form plus Y kilojoule. Okay, so what we have to find, we have to find heat of formation. Okay, we have to find heat of formation We have to find heat of formation of CO. Heat of formation of CO. Okay, this we have to find. So guys, it's very simple thing. It's very simple thing. Very simple thing. Okay. Now see here, carbon plus O2 gives CO2. So this is plus H. So what we know? We know that heat will evolve. What we know here? See, plus heat. Heat will evolve. What will happen? Heat will be there. What will happen? Heat will be there. Okay, every steps, every reaction, heat will be there. Okay, so here what will happen? This plus H plus Y, this is what, like heat is evolving. So here what we will get? What we will get here? देखो भैया सिंपल चीज है. Here what we will get? Here we will get is minus x. Here what we will get? We will get the minus x, and here we will get a minus y. Here what we will get? Plus x. When it will go to that side, it will become minus x, and plus y, when it will go to that side of the heat, it will become minus y. Okay, why? Because heat is evolving here. Now see here what I have written in the reaction. Carbon plus O2 gives CO2 plus heat. Okay, plus heat, but when it will go to that side of equal, what will happen? Plus will become minus. So that's why it is a minus value. Again here it is a plus heat. So what is the delta H? Minus value. Again it is a plus heat. So delta H is minus value. Means what? If suppose here CO2 minus heat, in place of plus heat we will take minus heat. So then delta H will become, in place of minus it will become plus. So that is the thing. Okay. Okay. So guys, plus means what? Heat is absorbing, heat is evolved, right? Heat is involved. Okay, so what is happening? Heat is involved. So heat is involved means what? What will happen? Wait a minute. 1 minute. Right. Okay. So what will happen whenever, like, whenever any reaction is happening, what is happening? Heat is evolved. Heat is evolved. So heat is evolved. Evolved means what? Exothermic. Exothermic means minus. Directly you can remember this thing, guys. If you are not getting, like, plus is this side, plus heat, when it will go that side will become minus. Okay, so delta H is minus. Here the heat is plus, when it will go that side it will become minus. If suppose this side heat is minus, if it will go that side will become plus. If you cannot able to understand that thing, just keep in your mind this thing, guys. So what will happen? Any reaction is taking places. So what will happen? Heat is evolved. Any reaction is taking place, what is happening? Heat is evolved or heat is released. Heat is released. Heat is released. Heat is released. Right? Whenever reaction is happening, what is happening? Heat is released. Right? When you will form a product, what will happen? Heat is released. So when heat is released means which process? Exothermic. Exothermic means delta H is negative. Okay. Here also plus heat means heat is evolved or heat is released. So if heat is released means exothermic, delta H is minus. Here also heat is released. Right? Whenever the reaction will happen, what will happen? Heat will get released. Heat will get released means exothermic. So exothermic means delta H is negative. So that's why here also plus X. Plus X means this plus indicates the heat. Plus X or plus Y here indicates the heat. Okay, plus X or plus Y indicates here the heat. Okay, so if heat is what? Plus X. So what will happen? Whenever the reaction will take place, heat will get released. Whenever reaction takes place, heat will get released. So whenever heat will get released, what will happen? Delta H. Delta H is minus X. And here also what will happen? Here also the heat will get released. Heat will get released. Release means exothermic. Exothermic means delta H is minus. Okay, so here delta H will become minus X, delta H will become minus Y. Correct? Yes, sir. Okay. Now guys, what we have to do? We have to find the heat of formation of CO. Heat of formation of CO, carbon monoxide. We have to do a formation of carbon monoxide. So formation of carbon monoxide means on the product side we want carbon monoxide, right? Formation of carbon monoxide means what? Formation of carbon monoxide means on product side I want carbon monoxide. So you can see here in this we don't have any carbon monoxide. In the first reaction we don't have any carbon monoxide. The first reaction I will write as it is. First reaction, what I will do, I will write as it is. First reaction I will write as it is. So for first reaction delta H will remain as it is, minus X. Now second reaction we can see we want carbon monoxide on the product side. We want carbon monoxide on the product side because formation of carbon monoxide, formation means product side. Formation means product side, right? Formation means product side. So product side we want carbon monoxide. So what we will do? Carbon monoxide is on the reactant side. We will do reverse. We will do reverse. Wait a minute. What we will do, guys? We will do the reverse. So reverse means product will go to reactant side and reactant will come to the product side. So reverse means what will happen? This CO2 gives CO2 which in the gaseous form gives CO in the gaseous form plus half O2. Now you can see here formation of CO means formation means what? Product, right? Formation means product. So product side we want the CO. We can see product side we got the CO. Okay. And here what we did, guys, here we have reversed the reaction. If we are reversing the reaction means product is bringing towards reactant side, reactant will bring towards product side. If it will reverse it, product will go towards reactant side, reactant will come towards product side. If we are reversing, the sign will also get reversed. So delta H will become plus Y. Delta H will become plus Y. It was minus Y, it will become plus Y. If suppose here it was plus Y, so then that time it will become minus Y. Because the thing is we have to do the formation of CO. Formation means what? Yes, on the product side we want the CO, but in the second reaction we will see CO is on the reactant side. We will do ulta. So reactant will go towards product, product will come towards reactant. Like this we will write. So whenever we will write like this, so what will happen? Delta H will become ulta. So it was minus, so it will become plus. If suppose it was having plus, so it will become minus. Now you can see here formation of CO. Okay, that's it. So this is the formation of CO. We are getting the CO this side. Okay. That's it, formation of CO. So what is the process? The process is Y. So we will get the delta heat of formation, delta HF. Okay. Heat of formation. So delta H heat of formation directly we will get for CO is, that's it, guys. See this, what will happen? Y minus X kilojoule per mole. Kilojoule per mole. That's it. Y minus X. Heat of formation of CO means on the right hand side we will bring the CO. That's it. On product side will be the CO. Okay. Right. So what will happen? Just we will change the sign. So it will become Y minus X. This is plus Y minus X. Or you can write like this also, minus X plus Y. Whatever you want you can write, kilojoule per mole. That's it. So just we have to see that how we are going to do the formation of this, whatever it is given. Okay. However we are going to get like whatever it's given. Okay, so according to that we will do the delta H and then we will get, because what we know, summation of delta H of every step. Summation of delta H of every step. We will do the sum. So here we did the ulta because we have to do the formation of CO. CO is present on the reactant side. We have to keep the CO on the product side. That's it. Okay. So if you will do the reverse of the reaction, then the sign will also get reversed. This is very important. Now next question is carbon, which is carbon. Next is carbon, which is in a graphite form. Carbon, which is in a graphite form, reacts with oxygen, which is in a gaseous form, will give carbon dioxide, which is in a gaseous form. So here delta H is minus 50 kilojoule. Then next is carbon, which is in a diamond form. Carbon, which is in diamond form, reacts with oxygen, which is in the gaseous form. Okay, it will give carbon dioxide, which is in gaseous form, and delta H is equals to minus 80 kilojoule. Okay, so suppose this is delta H1, this is delta H2. Okay, so we have to do the delta H. We have to find the enthalpy of reaction. Enthalpy of reaction where carbon in the graphite form will give the carbon in the diamond form. Okay, this we have to form. So first of all, what we will write, we will see, we want the carbon in the graphite form in the reactant side. So see here, carbon in the graphite form, it is in the reactant side. The first reaction we will write as it is, carbon which is in the graphite form reacts with oxygen in the gaseous form. We will get the carbon dioxide in the gaseous form. So this delta H will remain same, -50 kilojoule. This delta H will remain same, -50 kilojoule. Okay, चलो ये थोड़ा अच्छा से लिख देते हैं. delta H will remain same, -50 kilojoule. Okay, now we have to see the carbon which is in the diamond side, it is present in product. Carbon which is in the diamond form, it is present in the product side. But you will see here the carbon which is in the diamond form, it is present in the reactant side. So what we will do? Joldi joldi bolo re. Joldi joldi. What we will do? Yes, we will do ulta. We will do opposite. So what will happen? When we will do opposite, we will get the CO2 which in the gaseous form, it will give carbon which is in the diamond form plus oxygen which is in the gaseous form. So what will happen for the delta H? Arey oh pyare, joldi joldi bolo re. Yes. See here, the carbon, we want the carbon which is in the graphite form, it should be on the reactant side. So we'll see the first reaction. Here we can see the carbon which is in the graphite form, it is present in the reactant side. The first reaction will write as it is without any change. So if we write as it is, the value will remain same without any change. Now in the second, what they said that carbon which is in the diamond form, it should be present in product side. So but you will see here the carbon which is in the diamond side, it is present in the reactant side. So what we will do? Joldi joldi bolo re. We will interchange. So what will happen? The product will come on the reactant side and the reactant will go on the product side. So you will see here O2 will get moe, CO2 will get moe. So first thing is what, guys? First thing we did the ulta. Product will come to reactant side will go to product side. If we are doing change, so what will happen? Yes. Then that time what will happen? There is a change in the sign. The value will remain same, the sign will get changed. If it is plus, it will become minus. If it is minus, it will become plus. So here this is minus, it will become plus 80 kilojoule. Ashte macha ashte. So see here, carbon in graphite form will give the carbon in the diamond form. Bas itna sa khwab hai. Delta H we have to find for reaction. So what we will do? Delta H for reaction means summation of delta H for every step. So we'll do this delta H1 here plus delta H2 here. So delta H1 here is -50 plus delta H2 here is 80. -50 plus 80 is plus 30 kilojoule is the correct answer. That's it. Khalas, guys. Okay. Next we will come for the bond dissociation energy. Next we will write bond dissociation energy. Very simple, guys. There are two words, dissociation and association. Dissociation means breakdown. Association means again we will combine. Dissociation means breaking down. Association means combining. Okay, so they said bond dissociation energy means breaking of bond. So energy required to break the bond, that is bond dissociation energy. Dissociation means breaking down, association means combine. The bond dissociation energy means energy required to break the bond, right? Energy required to break the bond, that is bond dissociation energy. So bond dissociation energy we will write here, energy required to break. So whenever we talk, guys, we will talk in the standard condition. The standard condition means energy required to break 1 mole. Energy required to break 1 mole of a specific bond. So we know that which bond we have to break. So energy required to break 1 mole, because 1 mole is what? Standard form. So every time we will talk about the standard form. So energy required to break 1 mole of a specific bond homolytically in a molecule. Homolytically in a molecule. Very important thing, in a gaseous state. In a gaseous state to form free gaseous atom. Free gaseous atoms. Okay, so here the bond dissociation energy, इसको हम लोग ऐसे लिखेंगे. Okay, delta H bond. I will write not Y because this is standard बोलेंगे. Standard bond dissociation energy. Standard bond dissociation, because this indicates the standard bond dissociation energy is this. Okay, means standard bond dissociation energy. So what is this, guys? Energy required to break. Standard means we will take the standard. The standard means what? 1 mole, right? Energy required to break 1 mole of specific bond homolytically in a molecule in gaseous state to form free gaseous atom. So molecule which is present in the gaseous state, we will break to form a free gaseous atom. Molecule will break into atom. Okay, so guys, here we have to see this. There are two words, homolytically and heterolytically. So homolytically and heterolytically, I will tell you. Suppose if I will take a bond of hydrogen chlorine. Okay, if I will take a bond of hydrogen chlorine. So we know hydrogen is having 1 electron, chlorine is having 1 electron, right? Hydrogen is having 1 electron, chlorine is having 1 electron. So if I will talk about homolytically, homo means same. Homo means same. Same means, see, if I will break the bond here, so what will happen? Same means same 1 electron will go to hydrogen and same 1 electron will go to chlorine. So homolytically means homo means same. So if we will break the one bond which is having one bond, means obviously we know 2 electrons. When we will break this one bond, so same means same 1 electron. 1 electron will go to each atom. So that is same. Same means same number of atoms. Sorry, same number of electrons will go to atom. Same number of electrons will go to atom. So same number of electron will go to atom means, you can see 1 electron will go to this atom, 1 electron will go to this atom. So it's called as homolytically, means same number of electron will go to each atom. 1 electron, same number of electron will go to each atom. Another one is heterolytically. Hetero means different. So different means if I will break this bond, so what will happen? This both electron will go to one atom. This both electron will go to one atom. That is hetero, means not same. So this what will happen? This both electron will go to any one atom. So that is a heterolytic and heterolytical, and this is the homolytical. So but what we want? We want homolytical. So that's why one electron will go to each atom. So this is the bond dissociation energy. Okay, so bond dissociation energy is always a positive energy. Bond dissociation energy is always a positive energy, because what will happen? For breaking a bond requires energy. For breaking a bond will require the energy. So we will take the energy. Means endothermic. Endothermic means plus. So that's why it's a positive energy. Why? Because for bond breaking we require the energy. So if we'll take the energy, what is that? That is called as endothermic. But here, guys, bond dissociation energy, we have a different formula. For bond dissociation energy for the reaction, okay, so we have a different formula. We have a different formula, guys. See, bond dissociation energy, if you have to find for any reaction, we have a different formula. Here the formula is, we will take the summation. Okay, summation of bond, what we will do here, guys, we will take the summation of bond enthalpies summation of bond enthalpies of reactant side minus summation of bond enthalpies of product side. So this is different, guys. Bond enthalpies of product side, this is different. See, before what we had studied, before we had studied that it will be from where it will be product minus reactant, right? Before we had studied for the process is product minus reactant, but only for this bond dissociation energy, only for the bond dissociation energy, what we will do for finding the enthalpy change for the reaction for bond dissociation energy, we will do the sum of bond enthalpies of reactant minus sum of bond enthalpies of product. What we'll do, we'll do the sum of bond enthalpies of reactant minus sum of bond enthalpies of product. Okay, so here only, guys, here we have one more thing. Okay, first we'll solve the one problem upon this. How we will see, it is a simple thing, just we have to take the bond enthalpies for the reactant side minus the sum of bond enthalpies of product side. Before we did the same, just before we was taking first for the product side minus reactant side, but here first we'll take the reactant side, then minus we'll take the for product side. Okay, so let's see the question, guys. So this is the given, n single bond n is having, okay, चलो इसका first पूरा question लिख देते हैं, guys, पूरा लिख देते हैं. based on the given values, based on the given values of bond dissociation energy, based on the given values of bond dissociation energy. Okay, we have to find, based on the given values of bond dissociation energy, find delta F naught, means formation, right? Enthalpy of formation. This is what standard delta H means enthalpy, standard enthalpy of formation of N2H4, standard enthalpy of formation of N2H4 we have to find for this. So see, they had given n single bond n is having 159 kilojoule per mole. Then we have H single bond H is 436 kilojoule per mole. Then this is N triple bond N is having 941 kilojoule per mole. Okay, and then this we have a N single bond H, we have a 398 kilojoule per mole. Okay, the very important thing is, guys, what very important thing, this based, see how we will get to know, like we have to use this formula, because in the exam, in the question itself they said based on the given values of bond dissociation energy. Bond dissociation energy means we will get to know we have to use the formula of bond dissociation energy. The bond dissociation energy means reactant minus product, except the bond dissociation energy we will take product minus reactant. But in bond dissociation energy we will take reactant minus product. Okay, but here the very important thing, guys, they said find the enthalpy of formation of N2O4. So here, guys, we have to write the reaction how we are going to get the N2O4. This is very important that we have to write the reaction how we will get the N2H4. So how we will get the N2H4, we have to write the reaction upon that. Okay, so we will write the reaction N2, which is in the gaseous form, reacts with 2H2, which is in the gaseous form. We are going to get N2H4, which is in the gaseous form. So, guys, we have to know that the process of the formation of N2H4, the reaction process for the formation of N2H4. If you don't know this, the reaction, how to form the product, then it will be very difficult. The main thing is how we will get to know. Just we have to know N2H4. So N2H4 means 2N. So we'll take the N2 nitrogen gas, and then H4 means hydrogen gas with this 2H2. So we'll get the N2H4. So what we will do, guys, we have to find the delta formation of H0, right? So first we'll take the summation for the reactant minus product. So reactant means, see this, guys. First of all, okay, fine. Here. Okay, first this Second step, what we have to do is, second step we have to write in the bond form. So N2 means this is a bond form. N2 means this is a bond form. N triple bond N. So N2 plus 2H2, 2H2. So H2, 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 right? H2, H2. Then N2H4. N2H4 means this. N2H4, 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 N2H4. Okay. Now we will write down. Now we will do it. First, what we have to do, guys? First, we have to write down the process. First we have to write down the process, means first we have to write down the reaction. First what we have to do, first we have to write down the reaction, because we have to do the formation. The first what we will do, first we have to write down the reaction. So after writing the reaction, what we have to do, we have to write this in a bond form. We have to write this in a bond form. Okay, this, like this is a bond form. After that we will do formation, right? The first of all we have to take the reactant side. Reactant side means, see this, N triple bond N. N triple bond N is how much? 941. And how much N triple bond N? N triple bond N is 1. So 1 into 941 is 941. Plus, because what we have to do? We have to do the summation of bond enthalpy. Summation of bond enthalpies of reactant. The reactant first N2. N2 we will write like this, N triple bond N. So this is N2. N2, N triple bond N. So N triple bond N is 941. How much N2? 1 into 941. 941 plus H2. H2 means this, H single bond H. H single bond H is what? 436. So it will be 436, and how much H, this H2? It is 2H2. So 436 into 2. Minus we will write for product. Product, oh, product is very important, guys. See, product we have NN, right? NN single bond. NN single bond, how much? NN single bond is where? See, NN single bond is 159. NN single bond is 159. How much? 1, right? So 159 into 1 is 159. NN, see this, NN single bond. NN single bond is, value is 159. How much NN single bond? Just 1. So it is 151 into 1 is 151. Plus, see this, NH bond. NH bond is 1. NH bond is this 2. NH bond is 3, NH bond is 4. So what is the value of NH bond? NH bond is 398. NH bond is 398. So 398 into, how many NH bond is there? 1 NH bond, 2 NH bond, 3 NH bond, this 4 NH bond. So 398 into 4. So NH bond. Like this we have to do the bond dissociation. So first we have to write the reaction. After reaction we have to write in this bond form. After that bond form, we have to see that whichever the bond is present, we have to write down its value, which is given in the question, and how much is there. 1 means multiply with 1, 2 means multiply with 2, 1 means multiply with 1. So NH value is how much? 398, multiply with 4. So once you will do all these thing, you will get the answer. You will get the answer. Okay. So just solve it and you can find the answer. So what we will do? Chalo kar dete bhai. For you, I will do guys. So first is 941. 941 plus 436 into 2. 941 plus 436 into 2. We will get here, for this we will get 1813. Then minus, we will do this thing. 159 plus this one, 398 into 4 minus, we will get 1751. So when you will do this, 1813 minus 1751, we will get 62. 62, what is this? Kilojoule per mole. 62 kilojoule per mole. That is the answer. Simple. And here guys, here one more thing they will ask is mean bond enthalpy. Mean bond enthalpy. Okay, mean bond enthalpy. We'll write down the heading mean bond enthalpy. We'll write down the heading mean bond. We will write down the heading mean bond enthalpy. Okay, we'll write on the heading mean bond enthalpy. Okay, chalo theek hai. Mean bond enthalpy means very simple thing. Let's suppose I will write on one reaction. CH4, wait, CH4 gives CH3 plus H. So for that we have a delta H naught for this bond dissociation enthalpy. Bond dissociation enthalpy we have plus 427. Same again after CH3 again CH3 will give CH2 plus H. Okay, again this, for this again delta bond means standard bond dissociation energy we will get is plus 439 kilojoule per mole. Okay, then again from CH2 will give CH plus hydrogen. See, all are in the gas form, all are in the gaseous form, all are in the gaseous form, all is 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 in the gaseous form. So this is what, this is delta bond H naught, then this is delta bond H naught. So for this we have plus 452, all is in kilojoule per mole, kilojoule per mole, kilojoule per mole. Okay, then next again I will write from here CH, which is in the gaseous form, it will give carbon plus hydrogen. For this again this bond is what, plus 347 kilojoule per mole. Okay, so guys, see, main thing is what, main thing, if you will see here, we will see that CH4, from CH4 what we are getting, the final thing we are getting is carbon, okay, plus what, CH4 means 1 carbon plus 4 hydrogen, 1 carbon plus 4 hydrogen. So when you will find the whole delta H, then what we will do, we will add all and we are going to get 1665 kilojoule per mole. Okay, so now see what will happen here. What is the process? Mostly the process is carbon hydrogen bond, carbon hydrogen bond, carbon hydrogen bond, carbon hydrogen bond, right? So carbon hydrogen bond, if I will tell you, okay, what is the value of carbon hydrogen bond here in this process? In this process, what is the value of carbon hydrogen bond? So you will say carbon hydrogen bond, if I will take CH4, its value is this. If I will take CH3, its value is this. If I will take CH2, its value is this. If I will take CH, this value is this. So what I will say, wait. Why you are telling me the separate all these values? Huh? Just tell me the overall values. Now the overall values means what you will do, you will find the mean of this bond enthalpy. What we will do, we will find the mean of this bond enthalpy. Okay, what we will do, we will find the mean of this bond enthalpy. So that's what we called as mean bond enthalpy. So what we have to do, we will find the mean enthalpy for this carbon hydrogen bond. What we will do, this total, which is this 1665 divided by how many steps, 1 2 3 4 steps, 4 steps. Okay, so you will get something 406 kilojoule per mole. Okay, so this is the thing. Okay, so see what you will do, mean bond enthalpy means, if suppose we have a process, the process is from CH4, we will get this. Okay, CH4 means the carbon hydrogen single bond, it will split into CH3. Again CH3 means carbon hydrogen bond, it will get split into CH2. Again CH2, the carbon hydrogen bond, it will get split into CH. Again CH, the carbon hydrogen bond, it will get split into carbon. So what does this mean? This means that every steps 1 2 3 4, every steps we are doing carbon hydrogen, carbon hydrogen, carbon hydrogen, carbon hydrogen bond. So for every steps we have a different bond dissociation energy. Okay, so what we will do, we cannot, if like different steps, so which steps we will consider, I will say 427, no 439, 452, 347. So this time what we will do, this time we have to, for this type, For this type we have to find a mean bond enthalpy. Mean bond enthalpy means we will add all these bond enthalpy, divided by how many steps? 1 2 3 4, divided by 4 steps. So final we will say the mean bond enthalpy for carbon hydrogen bond for here this CH4 is 416 kilojoule. So we get to know, okay, mean bond enthalpy means average bond enthalpy for carbon hydrogen bond for CH4 is 416 kilojoule. So in place of remembering the bond dissociation enthalpy for each and every steps, it's better to find the mean bond enthalpy or average bond enthalpy, and just you have to remember the one. That's it. So it will become easy to remember the one in place of remembering the four, like different for different bond dissociation enthalpy for different steps. So suppose if it will be 6 steps, 7 steps, so it is very difficult to remember for 6 steps, 7 steps, right? So that's why what we will do, we will just find the mean bond enthalpy, or you can say average bond enthalpy. So what we will do, for every steps we will add, the bond dissociation enthalpy, and then we will divide with the total number of steps. We will get the mean bond enthalpy, or we will get the average bond enthalpy. So it will become easy to remember one rather than remembering for each and every steps. Okay, so this is for the His law, and then regarded that. So in the next video guys, this whole thermodynamics will get over, and then next video will be a bit lengthy. The next thermodynamics will get over, and then after that one more video in which we will solve the Ncert examples questions and then Ncert exercise questions. So another 2 videos thermodynamics will get over. So after that you have to comment that which chapter I will start, either equilibrium or states of matter or GOC. So you have to tell, like general organic chemistry. So out of these 3 chapters you have to tell me which chapter I will start in the next video. Okay guys, so thank you, bye bye. We'll meet in the next video for the thermodynamics.